Ladies and gentlemen, we're not doing a carbohydrate lab. That is for a different course. We are doing our methyl red synthesis today in lab. Methyl red is a diazonium dye. Diazonium. What does the dye mean? We got a lot of dyes. What does the DI right there mean? Two. What does azo mean? Always. What element are you talking about when you see azo? Always. No, the element is nitrogen. Every one of these dyes has two nitrogens in the middle. Diazonium, 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 diazonium. Good. We're making methyl red right now. You're doing it. Where was anthranilic acid? Which of the solutions? I need a lot of feedback today, everybody. So which solution had anthranilic acid? Solution A. What else was in solution A? HCl and NaNO2 and a lot of water, right? And we'll make this one purple. What's a good purple? Okay. Now, temperature, very important today. What temperature is your reaction mixture right now? 0 degrees Celsius. Absolutely critical importance. Because you're about to make this species here. What happens to anthranilic acid when you treat it with those chemicals? What do you get over there? You get another N. What color is the N? Purple. Yeah, make it bold. So where'd that N come from? Where'd this N come from? Nitrite. NO2 minus. Where's my formal charge that's missing, and what is it? A positive on the internal nitrogen. Nitrogen with 4 bonds is positive. Nitrogen with 3 bonds and 1 lone pair, that's this one over here. It's not positive. Don't do that. There, it made it positive because I put the positive there. Okay, good news. So this molecule is an intermediate. Intermediate called a diazonium ion. Make sense? 2 nitrogens, diazonium ion. Unstable above 5 degrees Celsius. Oh. Five degrees Celsius. You want to see what happens above 5 degrees Celsius? It's sad news. There'll be a lot of crying. Yes, among other things. Yeah, he said the N falls off. Yeah, it gets hydrolyzed off. Hydrolyzed off means broken apart by what molecule? Hydrolyzed means broken apart by what molecule? Hydrolyzed means broken apart by what molecule? Somebody was saying water. OH. Bold. Purple. If I had more time, I'd do this. Well, I got more time. Yeah. This is bad. Yeah. There you go. I don't want that. That's a phenol. A phenol. What's that mean? Phenyl group attached to what? OH. So no phenols today, please. What's happening? Let's see. You're doing this right now, and then you're going to be adding a new chemical pretty soon. What chemical is that? What organic chemicals coming up on your list? Sodium acetate, I'll give you that. It's organic, yeah. we'll talk about sodium acetate in another video, which is already present. Sodium acetate's role is the base to slowly bring the pH up. But the next organic chemical is going to be N,N-dimethyl aniline, right? Notice I got it from up there. And I got it from my target molecule up there at the top of the screen, methyl red. That's where we're going. And I think that arrow needs fixing, because that's going to be the end of our story, right? Yeah. Now you do want the thing to react. You do want it. There's where you want it to warm up, right? One of the steps you have it, you're adding this chemical, which you've all done, I think, or maybe not. Have we added this chemical yet? Yeah. And the reaction really doesn't start happening until you lift it out of the cold water, which is what, step 8? Then this reaction's happening, okay? So on your final, I'm just waiting for more heads to turn. You're going to be given another dye and asked to make it in the same fashion we made methyl red. So what we're going to be doing is called retrosynthetic analysis, okay? We're going to be running this thing backwards. You're only going to have the picture of the thing I want you to make. So for example, I'll pick disperse orange 25. So what I want to edit this to be the same as disperse orange 25. So instead of let's see, there's what took place of N,N-dimethyl. So I have to add another thing there and a thing here. Thing, yeah, very scientific, Dr. Whitaker. And a thing there. And that's going to be a CN. And I got that up to here. And then I have an NO2 over here. Don't worry, we'll color code it. We'll make it look pretty. And we don't have a carboxylic acid on ours. I believe I got this structure. And I'm gonna, wow, thank you very much. There you go. So it's a bit on the big side. And the green part should be this part here. And the pink part, this is all pink. All pink. So if that is my new target molecule, we're going to make that one this time. What green piece needed to be added to make that target molecule? What I'm trying to say is, what goes over this arrow? Trying to make it look like the other synthesis. Okay. Now, this is called the nucleophile. Nui, that's French. This is the electrophile. Make sense? What kind of charge does all electrophiles have? At least a slightly positive or fully positive charge, right? Okay. So how do you pick the nucleophile? I know it won't be color coded on your final. So this will not be this color coding. So go to black. The nucleophile has to have a neutral nitrogen in it or a neutral oxygen in it attached to benzene. This A lot of you are not familiar with that. That is not a neutral nitrogen. It's a very common group called nitro. And it is not ever going to be part of your nucleophile. Nitro looks like this. It's the opposite of a nucleophile because the nitrogen has 4 bonds. And formal charges up the wazoo. And I don't know what that expression means. Haven't heard it in a long time. There's your nitro. Way too big. There you go. Is there a lone pair on that nitrogen? Therefore, is that nitrogen a nucleophile at all? No. Don't circle the green. I want to circle the green piece here. And this is the green piece, correct? Because this nitrogen right here has a lone pair. That means it's a nucleophile. So find the piece that has either a nitrogen or an oxygen with a lone pair. And that's the green piece. That's the green piece. That's good. You need that for the last step of your synthesis. What did it react with? I need the pink piece. Well, look at the coloring here. The other ring is the pink piece, and it had to have one of the nitrogen. So I want you to tell me what to circle here and call pink. The whole nitro, the whole benzene. Tell me when to stop. The first N, thank you. And what kind of nitrogen was it in the square box here? You got to make it the same kind of nitrogen, everybody. N-triple-N, right? And what color is that other nitrogen, and where the heck did it come from? Triple and from sodium nitrate. You got to know that, because test A, you got to tell me that N, everything else is pink. Oh, I'm going to get a pink box. I don't want a pink box. Pink. Pink. We got the pink. No, we didn't get the pink here. Color coding. You've got to tell me that you're going to use these chemicals, right? Oh, I see it. Yeah. Wow. It's awkward using ChemDraw this way. So we're gonna, I don't know. This new ChemDraw will not even let me highlight an arrow. Somebody write a ChemDraw a letter. She's on it. Thank you. I used to just be able to click on an arrow and move it. I can't anymore.
They should name it after you.
No, please don't. Never put my name on anything. That's an insult. So, no, it's not an insult. But from the way I talk about people's names, it's kind of, it's not a good thing. Okay. All right. Yeah, what goes before this arrow? I got the purple for this thing. I don't have any of the pink. Hey, this pink became this pink. You see it? What's the only difference? NH2 instead of N-triple-N. Got it? NH2 instead of N-triple-N. I'm going to go find the pink, grab it. That's methyl red. It's wrong pink. Man. That's an NH2 that I circled on the top, right? Yeah. Is that the end of the story? You just designed a synthesis of, can't even remember which one it was. It was this first red one. Is that right? This one? Oh, man, they're very similar, aren't they? They're not very similar. They're identical. Somebody's in trouble. Somebody's in trouble. They're both the same. One of those is wrong, clearly, right? We don't know. But, you know, on the test, I'm only going to give you a picture for one. Disperse orange ends where?
At the end, I think.
Oh, C243F22Expt26MethylRedSynthesis. Yes, versus always. They are different. I apologize. I already complained off screen about the resolution of the document I found. I like it because it had a lot of dyes on it, but it's fuzzy. So yeah, we're making disperse orange 25. Thank you. Sorry for the confusion. So on the test, it would say, here's the wording. You ready? Show a synthesis of disperse orange 25. And that's all. It doesn't even have the picture. Now they're interested. I only have the words disperse orange 25. What's your first job? Open. I would use the CRC or the Merck, one or the other, and find disperse orange 25. Let's do a sample research for methyl red. CRC. Where did you go? I told some people to go somewhere before class. I went index for indicators, and most students came up with a table in the D section. I think D136 for some of the students. So yeah, and they're in order on that table, in order of increasing pKa. So they're not alphabetical, but I believe it's on the first page on the bottom left. And one of the other questions on your test is, what is the pKa of a dye from its name in both the CRC index? And then another question, what's the pKa in the Merck index? So right now we're working on the CRC, and you found it, methyl red on page D136 or whatever. It gives a range. CRC says what? Give me the range, beginning and end. To 6.0. But the question I ask on the exam is, what is the pKa? I'll tell you what these numbers mean. It begins changing color at pH 4.8. It finishes changing color at 6. In the middle is a mixture of colors. Okay? All right.
And how do we find
the pKa is in the middle of this. Merck index, we're doing that later. And pKa, therefore, this isn't given to you, 4.8 plus 6.0 over 2, the average of the range. 4.8 plus 6.0 divided by 2 equals 5.4, you said? Good, that's one question on it. Now, somebody said, how do you find it in the Merck index? Good answer here, it's easier. Under M for methyl red. Do they also give a range there? What do they give there? 6.2. pKa 5. Starts lower, ends higher. I'd say 5.3. Is that right? Yeah, there's 0.9 between each number. Yeah. pKa equals 5.3. Not exactly the same result. Interesting, huh? So there's 2 points on your test. You'll do it for a different dye. I don't believe the disperses are in there. I think that's a company's trade name. So I won't be giving you a disperse of any variety. So when he did look for it already, and it's not there. But we'll just pretend methyl red was the example. I've got many dyes from the CRC. I've already verified they are in there. Okay. And I think that's pretty much it for the synthesis. You got to find the nucleophile and the electrophile. Can you remind me how to find the nucleophile? What makes this qualify as the nucleophile? It has a nitrogen with a lone pair, or it could be an oxygen with a lone pair over there. And the other one by default is now the electrophile. The easiest way is to find the nucleophile first. The other ring is now the electrophile.
Do we have to use the Merck index to find the picture of it?
the Merck will give you the picture faster than the CRCs. He asked, should we use the Merck index to find the picture of it? I suggest you do that because the Merck index pictures are right there. CRC, it's one extra level. You got to find the molecule, then go to the data section for the whatever data, then the picture index. And it's not even in the right section, the data for this indicator numbers. So starting with Merck is best. And I may ask for a use if it's from the Merck, right? Does somebody still have the MethylRed page open on Merck?
Yeah.
Does it have a use at the end of the entry or a therapeutic category? It's an indicator for alcohol with alcohols as a solvent. You write that down if you're asked for it. And I believe that's a pretty good video. Oh, one more point then. Sorry. We need to know how to predict the product of an acid-base reaction with these indicators. So last thing we're going to do, I got my methyl red there. I got my disperse orange 25 here. And you're going to be asked, what is the product when your indicator reacts with 1 mole of HCl? 1 to 1, I'll just say here. And you need to be able to know which nitrogen picks up the proton. And it has everything to do with resonance. Okay, so where does the proton go? Me and moving arrows again, not a happy camper. We're going to zoom. Whoa. The mechanism tells you which nitrogen is the appropriate nitrogen. You got a lone pair there. Yeah, I think it should have been about right there. And we have HCl over here, right? HCl. Let's do the mechanism. Object fixed angles off for mechanisms. Hey, did you know if you're going to take Chem 244, you're going to learn how to use this program? I bet you didn't know that. I will train you. Oh, that's where it's going to go. I need a shallow arrow. So my question for you, given where the arrows started is here, right? Which of the two nitrogens is going to get a proton with this mechanism? The one that's proximal to this nitrogen or the one that's distal? The distal. Yeah, there's going to be a double bond here. There's no H on that one. It goes there. So, hey, this mechanism tells us that when you have to put a proton, what you're going to, and this is good. This is practice for ChemDraw. You got to get rid of that, get rid of that, get rid of that. It's going to fill in the H's. Just pretend ChemDraw is, he's, weird. I'll put it on there. And it's a black H. Man, it's too big though. Just shrink it. Now we're not finished. You're not going to get your 2 points. What else do you have to put on that thing? You've got, I don't care about spectator ion. This nitrogen has 4 bonds. It's the only nitrogen here with 4 bonds. That's the correct answer. You need that plus charge. This is the protonated form. I believe that color is yellow. Deprotonated form is red. Is red. And protonated form is yellow. Yellow doesn't show up very well. Wow, that's useless. Yellow outline. What a brilliant suggestion. Yellow shadow box. Now let's just do that. Okay, so can you just predict the structure for the protonated form of this thing without doing the mechanism? We got everything we need on the left. Which one is the resonator? This nitrogen here, or the one that doesn't even have? We can't. No, it's this one. So you're going to protonate pink. Protonate pink. That's a big long bond, isn't it? Missed. Double bonds are not going to be here. Oh, it's not big enough for me to erase double bonds. Sigh. I can't erase that double bond unless I go big. It's right there, right? Finally. There you go. And where's the plus charge on that one? Yeah, the former nucleophile. I like that. The former nucleophile. It was a nucleophile towards a proton, so it's a base. And here's the conjugate acid. We good? So that'll be your document, and that's all we got for today.